In this part of our series of instructions on EASA's Airworthiness Regulations, we'll be looking at Regulation 748/2012. Specifically, Annex 1 of that regulation, called Part 21, which relates to initial airworthiness. Regulation 748/2012 is part of Annex 2, Airworthiness, within the basic regulation. Annex 1 of Regulation 748 is what we call Part 21. Part 21 is a numbering system that comes from the FAA original category for design and certification. It's been harmonized with EASA's numbering system. So Annex 1, Part 21, deals with certification of aircraft, products, parts, and also the establishment of approval for design and production organizations, as well as their oversight. So by way of introduction, what does EASA certify? Well, EASA is responsible for the certification of what are called products, products being aircraft, engines, or propellers, or indeed other parts to be installed on the aircraft, as well as certain non-installed removable equipment. A certification of any of these products is an independent assessment of a design and a confirmation that it meets the standards of safety and environmental protection that were established and evolved over decades, and in the case of aircraft, that is suitable for operation. European rules and oversight mechanisms, including the maintenance of products, ensure that the initial levels of safety from the design are maintained throughout the product's life. Essentially, each individual element fitted on an aircraft shall be in compliance with the approved design of that part and also of the aircraft as a whole, including engines, props, parts and appliances, standard parts and materials, including raw materials and consumables. So there we have the definition of product: aircraft, engine, or propeller. Appliances are broader in nature. They're really kind of any kind of removable mechanism or instrument, part, apparatus, could be a pump, an air cycle machine, a generator, things of that nature. By parts, we really mean parts that are a permanent part of the aircraft's design, structural design, and mechanical design. So an appliance is a description of an independent part, if you like, something that can be removed and is not part of the basic airframe, so to speak. So what is a type design? Well, a type design is really everything required to describe the design and the manufacturing and in-service operating requirements of the aircraft or product. So it consists of the drawings and specifications, design drawings, wiring diagrams, and structural drawings. It contains information on materials and processes. They will invariably be in the drawings themselves, materials and manufacturing processes, methods of manufacture as well. Obviously, that's quite an important thing in terms of being able to make your aircraft using specialized methods. And also an approved airworthiness limitations section, which describes how the aircraft or part can be operated safely and its limitations. So the type design deals not only with the product configuration, but also with the production methods as well. It should be noted that any deviation from the original type design is a change, which must also be approved. This is to ensure that series products, upgrades, etc., are not inferior to the prototype identified by the type design. You know, if we put in modifications, it's for a good reason and it should improve the aircraft or create more utility. Should certainly not degrade its airworthiness. So Regulation 748/2012, Part 21 under Annex 1. So 2012-748 is the cover regulation to all rules relating to aircraft and product design, certification, production. as I said earlier, also includes the requirements for approving design and production organisations. So it's divided into two sections, Part 21. Section A are the rules for industry organisations, and B are the requirements for the competent authorities. That's the national authorities responsible for overseeing design and production organisations in their member states in Europe or other countries. So we will focus on Section A because that's applicable to us as operators and maintenance organisations. Section A contains 14 subparts, Part 21 subparts. We'll go through each of these individually and take a high-level look at what they contain. So Subpart A. This subpart establishes the general rights and obligation of the applicant and holder of any certificate that's been issued or is to be issued in accordance with the Annex. So it establishes general rights and obligations. The obligations required by the applicant can be undertaken by another organisation, say a subcontractor, on behalf of the applicant, providing there's an agreement in place for the certificate holder to properly discharge its responsibilities. So there are requirements for dealing with failures, malfunctions and defects. If a design organisation produces a part, it has to be able to support that part's health, if you like, in the long term, which includes reacting to any in-service defects which appear, investigating them and reporting them. Any airworthiness directives that might be released by the authorities, particularly the NAA, against the product or part or aircraft made by the type certificate holder, it then becomes a responsibility for the TC or STC holder to respond to the airworthiness directives and come up with a solution. Some kind of technical fix, which is usually a modification or an upgrade. Subpart A also defines cooperation as required between design and production bodies, between the 21J and 21G organisations. It defines the requirements for record keeping, the manuals and instructions for continued airworthiness, and the access requirements to allow the authority, the National Aviation Authority, to come inside to an organisation and inspect it and have a look at how well it's doing and to monitor its performance. Subpart B relates to type certificates and restricted type certificates. So it contains really all of the requirements for obtaining a type certificate for an aircraft engine or propeller. This generally requires the development of a certification plan and the need to ensure full compliance with airworthiness and environmental requirements. Also, the issue or generation and issue of operational suitability data and performance of the necessary testing to show compliance, and that may include flight test. The application for a type certificate is only acceptable from the holder of a design organisation approval. You have to be a competent design organisation and approved to create designs and go through the compliance process before you can apply to have a TC. So what does a type certificate demonstrate? Well, a TC implies that the aircraft manufactured according to the approved design can be issued an airworthiness certificate. And to meet those requirements, the aircraft and each of its sub-assemblies, or part and each of its sub-assemblies, must be approved, and they must meet the relevant requirements in the particular standards. In the case of appliances or removable parts such as electronics boxes, avionics, pumps, instruments, etc., these type of sub-assemblies must meet the requirements in the applicable technical standards order, TSO, or in Europe, the ETSO. Other things in Subpart B, rights and obligations of type certificate holders, what they're responsible for doing, how compliance will be demonstrated, both for airworthiness and environmental requirements. Now, the agency, EASA, evaluates compliance against the relevant technical code, which is the certification specifications, for example, CS25, and this is done against the certification plan. So the process of type certificate or obtaining a type certificate involves developing a certification plan, identifying which of the CS standards are applicable to the design, and then demonstrating compliance against those standards by means of inspection, test, or flight test as well. So that's the process here, shown in this flowchart. Starts off with developing a product design specification, and in consultation with the EASA, the correct certification basis, that's the set of CS rules which apply for that particular design, are confirmed. And also in the course of developing the certification plan, the means of compliance, the method of demonstrating compliance against each of the certification specs is also noted, and that could be by design analysis or test. At this stage, that's the issue of the draft certification plan. Detailed design continues, and then when the design is further advanced, then a detailed examination of its compliance against standards can be carried out by reference to the CS standards 25, 29, etc., depending on the type of aircraft, and also in reference to the acceptable means for compliance, AMCs. And as required, tests will be carried out. Some of these might be witnessed by EASA, tests of product strength or flight tests of performance. On occasions, EASA may wish to be present. Another key part of this process is independent verification of compliance. So the design engineers initially decide on the type of compliance that needs to be demonstrated, the relevant specification, and then by virtue of examination of the design confirms that it does meet those specifications. However, this process needs to be independently verified by a completely different set of engineers which don't form part of the original design team, who can stand back and take an independent view of whether or not the design as created or as described is in fact in compliance with the intent of the CS standards or AMCs, or both. So once that's established and the CVEs, the certification and verification engineers, are happy and the head of airworthiness is happy, then a declaration of compliance can be made within the DOA, within the design organization, to say, yes, we've made a design, we're happy it meets all the EASA requirements, and then it's passed into EASA for their review and acceptance. So EASA do not at this point go through all the regulations again and have another look. They would rarely do that unless they had a particular question against one or two standards or one or two compliance statements. So they're basically accepting the fact that an approved design organization has gone through the process of showing compliance and has independently checked it. Having established that is done and all the requirements are met, then a type certification is issued. It's an actual certificate for the product. So here is an example of some certification specification requirements, in this case from CS25. There's one here for protection of structure, which simply states that the piece of structure in the design should be protected against deterioration and weathering, etc., corrosion. And a second requirement there, a different one, CS25611, which means the design must be inspectable, there must be access and necessary in the design, particularly for mechanical design, that adjustment can be made, lubrication can be made for the purposes of keeping the parts serviceable. But that's just a couple of examples. Subpart D relates to the processes and requirements for making changes to an existing type certificate. So a type certificate exists for an aircraft or a product, and the type certificate holder wants to make a change to that. In fact, the only people that can make a change to a type certificate under this subpart is the TC holder themselves. Otherwise, we have to go to Subpart E, which relates to supplemental type certificates. So Subpart D really relates to changes to an original or existing type certificate made by the original type certificate holder. This is for major changes. For minor changes, any person can apply to the agency for approval of a minor change because it doesn't need recertifying in the same way. A minor change, by definition, is any design change which has no appreciable effect on the mass, balance, structural strength, reliability, operational characteristics, noise, fuel venting, exhaust emission, or any other characteristics affecting airworthiness of the product. So a decision has to be made. Is the type of design we're doing have any of those major effects? If it does, then we cannot call it a minor change. It has to be a major change. Subpart E establishes a procedure for the approval of major changes to the type design under supplemental type certificate procedures and establishes the rights and obligations of the applicants for and also the holders of those certificates. So this relates to major changes to a type certificate by a design organization other than the original TC holder. So it's quite possible for a design organization to come up with an STC on, say, a Boeing aircraft. Boeing is the type certificate holder of the aircraft, but you can do an add-on modification. For example, this illustration here shows an electronic flight bag, which has been installed in the cockpit, I think, of a Boeing aircraft. That would be carried out by a supplemental type certificate by an independent design organization, although that design organization may refer back to Boeing for certain design information, but that's by the by. It's not the core of the process. So the Subpart E content also includes how to apply for that, rights and obligations, and European approval part marking, because every part that's generated under a design in the EASA system has to be traceable back to its origin and back to the original design data, and that requires part marking. There's also a requirement for operational suitability data, which is data to be used in service for the modification, like flight manual supplements and master MEL changes and performance charts or other limits and limitations. So supplemental type certificates, they are, in summary, a process which allows an independent design organization to create a modification on an existing type certified aircraft and sell that product in the marketplace, having got EASA certification for it. So it's quite desirable from a commercial point of view to have an STC which you can market. Subpart A relates to production of parts for aircraft against a design. It establishes a procedure for demonstrating conformity with the applicable design data of a product, part, and appliance that is intended to be manufactured by a production organization. So the type certificate holder produces its design, or the STC holder produces a design and describes it in drawings and manufacturing information. But that part has to be made by an approved organization. So how do we do that if the production organization has either no requirement or no business interest in getting a full approval under EASA? Well, we call that the production without POA approval. And it's used when Subpart G, which is the next part we'll be looking at, is not appropriate. For example, if it's a short production run of parts, or it's a part of a development process where the release of a product, part, or appliance is needed before the organization can get its Sub-G approval, Subpart G approval, then this process under Subpart F allows a less restrictive or a simpler approval of the organization as a sort of interim measure, really, or if it's just not, there's just no point in this organization going for a full production approval. And it's done with what's called a letter of agreement. So the applicant has to establish a satisfactory production inspection system, and it has to have a manual, which is similar to an exposition, and it demonstrates compliance with the relevant Part 21 requirements. So it goes quite a long way to meeting the requirements of a full production approval, but without actually having a certificate for production approval issued. So it's a simpler process, but in having this organized for the particular production organization, they're not allowed to release the parts as being certified for aircraft use. This has to be countersigned and validated by a national aviation authority representative. A full production organization approval, or POA, enables a production organization to be able to independently manufacture and issue conformity statements and Form 1s, which is an authorized release certificate, stating that the parts that they're making are in full compliance with an approved type design for aircraft or part. In order to have a production organization approval, you need a quality system with qualified personnel, and also you need to establish a link between the design organization that's providing you with the manufacturing data and the production organization, which is the Part 21G. So Subpart G also provides the rules for showing compliance for products, parts, and appliances with the relevant design data. So having manufactured the parts in accordance with drawings issued by a design organization, you have to demonstrate by inspection or test that they comply with the design intention. If they do comply, then a Form 1 can be issued, or in other cases, a certificate of conformity, which is issued typically for a complete aircraft. Subpart H, airworthiness certificates. Airworthiness certificates are issued for a new aircraft on presentation to the competent authority or national aviation authority. So for a new aircraft, the certificate of airworthiness is issued once it's deemed to have been in full compliance with the type certificate requirements and is fully serviceable and meets all the requirements for continued airworthiness, then a certificate of airworthiness can be issued. In the case of a used aircraft, not coming out of a factory but have been flying for a while, then an airworthiness review has to be carried out to check the state of that aircraft in terms of its maintenance records and its maintenance condition. And if that's all okay, then that can be presented to EASA, and an airworthiness certificate can be issued. If you're getting a second-hand used aircraft from outside of the European Union, there is more additional information required, such as the state of STCs, modifications and repairs, weight and balance, flight manual, and other records of to do with the aircraft. Noise certificates. Well, the noise certificates are a function of the design of the aircraft and testing, and they're issued upon presentation of the relevant documentation. So there is an application and approval process for noise, the noise footprint of the aircraft. With used aircraft, a noise certificate is issued upon presentation of noise information and appropriate records. ICAO Annex 16 provides a lot more information on this. Subpart J, Design Organization Approval, or DOA. Now, this subpart establishes procedures for the approval of design organizations. If you want to carry out any kind of modification that results in a type certificate or a supplemental type certificate, or do major repairs, you will need to have a design organization approval under EASA. So Subpart 21J includes all of the requirements for that. The idea being that once the organisation is improved, then the organisation can submit a statement of compliance for any design they do and have it directly accepted by EASA. So a DOA requires, again, qualified personnel, the establishment of what's called a design assurance system and an EASA approved design handbook or operational handbook. Subpart K relates to parts and appliances. And in this context, a part is considered a standard part, whereas it's designated as such by the design approval holder. So all parts basically have to go into an aircraft. We mentioned they have to be part marked. And they're usually part of a type certification process. So you can't really create a design without also creating some sort of parts for it. So we do our type certificate certification process under Subpart D or an STC under Subpart E. And that certification process considers all of the parts which go into the design. Repairs, Subpart M. Repairs are classified as either major or minor, and that follows the same evaluation process as Subpart D in terms of assessing the significance, the severity of the effect on aircraft mass, stability, structural strength, etc. And that classification, whether it's minor or major, can be made either by EASA or by an appropriately approved DOA. So what is a repair? Well, a repair is a restoration of an aircraft or part that's sustained damage to an airworthy condition, i.e. back to its original certified levels of integrity and strength. Elimination of damage by replacement of parts without any kind of design activity is a maintenance task and does not need approval under this part. But if you have damage to an aircraft structure, which perhaps a hole or a severe dent or some severe corrosion, that usually requires what it will require, the design of some sort of repair, a patch or additional structure put over the damage. And that, of course, needs to be designed properly and in compliance with the relevant regulations and specifications. So major repairs can be approved by the type certificate holder or STC holder for an STC or by EASA. Now, minor repairs can be directly approved by any design organisation approval holder or indeed again by EASA. So major repairs are really a form of process which is similar to getting a type certificate or getting an STC. There is an evaluation of the design of the repair against requirements. A European technical standard order is basically a minimum performance standard for specified articles such as avionics, components, etc. And it's the approval of both design and ability to produce the article. So the agency approves the design through a DDP, a Declaration of Design and Performance statement from the manufacturer or supplier, and also by reviewing the organization's design procedures. So there we have it. That's ETSO, which is a convenient way of independently obtaining approval for a part that can be installed on different types of aircraft. So the ETSO is separate to any particular aircraft type or type certificate. It's an independent approval which shows compliance of that part with minimum performance standards. And it can be indeed, you can have an aircraft system, an avionics component, for example, is approved under an ETSO or an FAA TSO, and can be installed on different types of aircraft. But that also then means that that part becomes part of the type certificate of the aircraft as well, because it's a key component. But it does enable the market to independently develop approved parts, which can be which can be sold with their own approvals, ETSO. Permit to fly is issued when the certificate of airworthiness is temporarily invalid or can't be issued, but the aircraft is nevertheless capable of performing a safe flight. For example, when returning an aircraft from an outstation back to base, when it has defect or damage that prevents it from operating with the standard C of A, and therefore it won't be able to carry passengers, but is otherwise serviceable and needs to be flown to a location for repairs. And that I've seen that happen in the airline industry. Sometimes an aircraft sustains damage. It's no longer compliant with its airworthiness certificate, but you can fly it back under certain conditions to get it repaired, obviously with nobody on board except the flight crew. The permit to flight, there is another occasion when you might want to issue a permit to fly, and that's when you need to do a test flight to prove the function and serviceability of a system or design before an STC modification can be signed off. So an STC might have been installed to an aircraft, new systems and functions, but they have not yet been tested because a flight test is required together with a report to approve them. Hence, technically, without that information, the aircraft would not be in compliance with design data, and therefore its certificate of airworthiness would be invalid. So again, in that situation, to finish the testing of a modification, a permit to fly is required. And that can be issued by the National Aviation Authority on application, or it can also be issued by a POA, a production approved organisation or a design organisation, which has those privileges. Subpart Q and its related guidance material requires proper identification of each part and appliance that is designed or redesigned, including parts to be incorporated in repairs, and you have to identify them by permanent and legible marking, and that's an applicable requirement for design organisations and for aircraft manufacturers. So Subpart Q designs how to go about the requirements for and how to go about marking the parts of an aircraft. And in general, that requires the name of the manufacturer, the trademark or symbol, the part number of the part, probably the serial number as well, and the EPA if the design data doesn't belong to the type certificate holder. So, and when that's done, an EASA Form 1 is issued with the part, which means that the aircraft part has been produced and all maintained in conformity with the approved design data and is a condition for safe operation. So the main reason for part marking is really traceability. So you can demonstrate that the parts are manufactured in accordance with the appropriate design data that forms part of the type certificate. Here's an overview of all the sub 21 parts, and you can see the relationships and applicability. And we can say that the structure of part 21 can be summarized as having two main elements: the requirements and activities related to an approved design organization, which are shown in blue here, and secondly, those subparts related to an approved production organization, orange. And then there are the subparts which have application to or relationship to activities carried out in some or all of these subparts. So the broader, more applicable subparts there, we have them E, O, K, and F, which are shown in yellow and grey. It's a little easier to understand it if you look at it this way. This diagram illustrates how various subparts apply across the activities being carried out by different parties in both the design organisation and production organisation, and also outside of those approved organisations. So Subpart A, which is general, it really applies to all areas of activity. So it spreads across minor changes and changes carried out by TC holders and STC holders. Subpart K for approval of parts and appliances, again, has got a broad application across any area of modification, which is TCs, STCs, or ETSO. Subpart Q, the part marking requirement, again, has a broad application in terms of the requirements to define what the part marking is in the design, and also to apply that part marking in the production organisation. Subpart M, which relates to approval of repairs, they're exclusively a design organisation requirement. And Subpart H, issue of C of A, is really exclusively a production organisation requirement. In this case, the aircraft manufacturer will issue the certificate of airworthiness, at least initially. So we're going to talk now about the requirements for obtaining a design organisation approval to become a DOA holder under Part 21. So Part 21, Subpart J, design organisation approval, it's a prerequisite before you can do any of these things, before you can get a type certificate for a design under Subpart B, before you can obtain a supplemental type certificate under Subpart E, or make changes to either TC or STC under Subpart D, before you can design any repairs under Subpart M, before you can gain an authorization for your ETSO part under Subpart O. So a DOA is required to do any of those things, and it's the DOA, the approval that is conferred upon the design organization, is really the means to assure confidence that the design of a product applies with the applicable requirements. So it's based on both the approval of the organization together with a demonstration of compliance and the certification of the actual design of the products. So EASA does not generally verify an STC design against the individual requirements for compliance. It delegates this requirement to the design organization with approval, the DOA, and it does this by approving the organization and its personnel as being competent and having the necessary procedures in place, including a design assurance system and a safety management system, and we will come to those shortly. So it's a system of delegation. EASA's oversight operates at the higher level, monitoring the performance and compliance of the organization, rather than directly observing its output in the office or on the shop floor. So the design organization approval is based on the principle of delegation. So the various organizations that seek approval and are granted it are issued with an approval from EASA, which allows them certain privileges. Now, this is quite different to the FAA policy, which does direct oversight and has individual delegates operating in design organizations and the US system. And they feed back information to demonstrate compliance to the FAA. But EASA doesn't work that way. EASA approves the whole organization and trusts it to follow its own procedures, which have been verified to be able to demonstrate compliance with requirements. So in simple terms, a design organization approval can be thought of as a license to operate. An aerospace company in Europe can neither hold a type certificate nor undertake or approve a design activity such as an STC without having a DOA. Now, the National Aviation Authority, or competent authority as it's called by EASA, is responsible for surveying the organization on behalf of EASA to verify that that design organization has qualified persons, necessary processes and management system in place to comply with the requirements of Part 21J and to competently carry out design activities. The whole point of this is that using design organization approval allows EASA to stand back and operate at a higher level and focus on strategic airworthiness issues. So what are the privileges of a DOA holder? Well, the submittal of compliance data in support of designs for type certificate or supplemental type certificate or ETSO. It enables the organization to classify repairs and design changes into minor or major. And if they're minor, they can approve them themselves within that organization. Major repairs and major modifications will still be go through the compliance process within that DOA organization, but EASA will have to approve their findings. But for minor modifications, the DOA holder can internally directly approve the minor mods and repairs. So obligations, the design organization is required to have a qualified framework in place, which is the management structure and leadership, clear responsibilities of all the required tasks, including internal oversight and compliance verification, and the necessary design procedures. The organization must also have enough qualified engineers and an independent internal compliance monitoring system. Lastly, and pretty importantly, the DOA must have arrangements in place with other organizations which are involved with the implementation of its modifications and repairs, mainly the Part 21G production organizations. But also there will be an interface with Part 145 maintenance organizations and Part M CAMO organizations. All of this has to be documented as process within the handbook of the DOA. So the primary elements of the design organization, there needs to be a quality system, which is in general terms, we call it a quality system, although it has other names as well, like airworthiness system, is the means to assure the quality of the design and has the objective, the quality system is really the establishment of verifiable procedures. Procedures that allow verification that a design complies with requirements. The quality system covers the control and supervision of the design covered by the application, and it includes also partner organizations such as Part 21Gs. The design organization applying for a DOA will also need to generate a manual or exposition. It's a handbook which identifies the organization structure, its procedures, and the product, and types of products and changes that will be modified or affected by design changes in that organization, as well as defining any subcontractor and partner organizations and their interfaces. And that manual, that handbook, should be available throughout the organization, and it will show all the nominated management staff and other relevant persons. So again, competent personnel, you can't do design activities without sufficient number of graduate engineers or highly experienced maintenance engineers, perhaps. And as well as having the people, you've got to have the accommodation and facilities as being suitable office environment and IT systems. The terms of approval defined in the handbook define the scope of the intended design work, what's going to be carried out, as well as the types of aircraft, products and appliances for which the DOA is applicable. The core of all this is the design management system. So the design organization shall establish, implement and maintain a design management system that basically includes two parts: a design assurance element, or DAS, design assurance system, which has clearly defined accountability and it shows the lines of responsibility through the organization. And secondly, a safety management element following the ICAO Annex 19 principles for SMS, so the SMS Framework. So what we're looking at is an integrated system, but first of all, we'll talk about the design assurance system. So EASA, through the Member State National Aviation Authority, approves the organization's design assurance system, or DAS. Right? This allows EASA to delegate responsibility to the organization for showing compliance with the airworthiness regulations and standards rather than having EASA do this activity itself. So the organization should have a process in place for a check that compliance is demonstrated for each aspect of a design change. Now, this is called compliance verification and must be a totally independent function. using specially qualified engineers, compliance verification engineers, or CVEs. These guys are not involved in the design itself, so they can do an independent check of compliance on behalf of EASA. So this independent checking function is a key pillar of the design assurance system. That's a little model there of a typical DAS. We have the organizational structure, which defines roles, allocated responsibility, who does what in the organization, and the necessary competence and experience required by those people. Then we've got the design processes and methods, which also include how compliance is shown against the requirements, and then resources. And all of this is monitored by an internal independent compliance monitoring system that's within the DOA itself, within the organization itself. And all of this is then subject to oversight by the National Aviation Authority or competent authority, who from time to time will carry out audits and inspections of the design assurance system to verify that it's working, it's functional, and the independent internal monitoring is also working. So there we go. The handbook, it's created and it contains the organization description, all the required policies, procedures used by the design organization, type of work carried out, interfaces with contractors, types of parts that are and components that are modified. And if the organization gets into flight test activities, it will need a flight test operations manual as well, which could be part of this manual. So this is an illustration of the complete design assurance function or process. So when we're talking about certifying a new type design or a supplemental type certificate design, it starts with a set of requirements. So the design organization establishes the requirements and then discusses to some degree, well, we will review these with the EASA to confirm which certification basis shall apply to the modification design, which CS specifications are going to apply, and you have to show compliance with each one of those. So the DMS really, the design management system is within that box there, and it does all those functions of doing the designing the certification program or compiling the certification program, and deciding how to demonstrate compliance against each of the CS requirements. So effective design assurance basically requires a continuing evaluation of factors that affect the adequacy of the design for its intended applications. So, as I just said, in particular, that the product or part complies with the applicable certification spec and also environmental protection requirements. So two main aspects have to be considered: how the planned and systemic actions are defined and implemented from the very beginning of design activities up to and including continued airworthiness activities carried out by the design organization, and also how these actions are regularly evaluated and any corrective actions implemented as necessary against negative findings. So anyway, that's the flow of the process. Requirements established. A certification program is put in place in coordination with the EASA, demonstrate compliance against each of the CS requirements, CS 25 or 23, whatever it is. Then that's verified by the Office of Airworthiness within the design management system and within the organization. You declare that you comply, and then that's passed back to EASA for acceptance. So this is similar to the model I showed earlier. And all of this is subject to the independent monitoring function. There's a further consideration called level of involvement, which EASA have introduced over the last 5 years or so, where if a design is likely to be more complex than normal or have novel features in it which haven't been used before, or is on a system which is critical to aircraft safety, or is being carried out by a design organization that has limited experience, then EASA will want to be more closely involved. So there is a kind of a scientific process for determining how much EASA will be directly involved in checking compliance against regulations, because normally they would leave leave nearly all of it, if not all of it, to the DOA itself. But in terms of more challenging and risky types of designs, say subject to those 4 factors there, the particular items of interest have to be identified. They're called CDIs, certification demonstration items. And for each one of those, you have to, not very many of them. It wouldn't be the entire product, but it would certainly be the compliance requirements against those unusual or challenging features. So that determines level of involvement. In fact, there is a kind of a risk assessment associated with that. There's a decision made about how risky this new design is. And based on the outcome of that assessment, EASA decide how much involvement they need in the design process, in the certification process. It's called LOI, and it's a complete process of its own, really, but it's an important element of STC and TC certification. Acceptable means of compliance for any of the requirements in the process, in the certification specs. The AMC is normally the CSs themselves, but also within the AMC defined in the regulations, there will be some statements made about what's acceptable, at least in general terms, and the types of acceptance which are granted for showing compliance against the design requirement are calculations, analysis, generation of reports, but also other means such as testing. In fact, there is a series of codes called means of compliance codes, or MOCs, which are used in the certification plans to identify how compliance with a regulatory CS standard will be demonstrated. And we've got them here. Basically, you can show that your design is compliant with the requirement either by a desktop evaluation of the nature of its design, so a design review. That could also include calculations or analysis and substantiation reports. So that's identified. The means of compliance is identified at the time you submit the certification plan, whether you're going to do engineering evaluation or whether you're going to do a bunch of tests either in the laboratory, on the ground, or in the flight, or you're going to do physical inspection on the production line or on the aircraft. So there's a number of ways. In fact, there's 9 different ways of showing compliance with a CS standard, and there are different types of documents issued in each case as part of the submission of compliance. Safety assessments are often put together for compliance reasons, particularly where you're talking about a more complex system, avionics or mechanical. And the type of modification that you're doing or proposing could have an impact on the functionality of the original system and the way it operates under conditions of flight. And to make sure that you've identified any risks, a safety analysis is carried out to verify the integrity of your design concept, at least at the initial stage. Flight tests are also often required, particularly if you're putting new equipment on the aircraft, which needs to be demonstrated to work at altitude. Could be radio equipment. It could be engine and modifications, structural modifications that involve fairings or additional parts on the outside of the aircraft, which may change its handling and vibration characteristics. So a schedule of flight tests would be drawn up for that type of situation and measurements made, and that all forms part, the flight test report and the analysis of it would form part of the submission for compliance at the end of the day on that project. Inspections are a physical means to verify that your design is going to be suitable. In this case, this is an example on this illustration here of a conformity test of some coupons, small samples of composite structure. And these small parts are representative of the larger structure. This is in the case of an electrical VTOL aircraft. To ensure that they, at that level, by testing the coupon, you can ensure that the material on the larger aircraft is going to meet the design material strength requirement. Now, this is a sort of test that will be observed on site by an EASA rep, or in the US, it would be an FAA DR. Safety management system. Now, safety management system is the second element of a DOA approval. And being compliant doesn't necessarily mean being safe. So in the past, we had what might be called a product-centric approach to managing safety, based on checking compliance of the design against the individual technical requirements. But now, as a result of introducing Annex 19 from ICAO, EASA is very much interested in making sure that the organization itself manages risk and has a safe methodology for operations. So the safety management of the DMS, of the design management system, that part of it will include all of the recommendations of Annex 19, which is the safety policy and objectives, a means to measure and track the organization's safety performance, a methodology for managing changes, and also continuous improvement, and the promotion and education of safety. And last but not least, an occurrence reporting system to report back any issues discovered in the organization, either in its design process or its control processes. Feed those back to the competent authority. So there we have it. This is the framework. This is the standard framework for SMS. You can read up on it, but it's essentially those four elements: safety policy, which is the commitment to safety, defines the organization's goals, the DOA's goals, defines methods and processes; safety assurance, which is assuring continued effectiveness of risk control strategies. And in fact, before that, we talk about safety risk management, which is a process of basically examining your processes in the organization and your operations to see if there are any hazards or risks, and then putting in place some control mechanisms and mitigations to prevent them becoming a negative event. Safety promotion, that relates to having training about safety and how to follow the safety management processes. So this whole approach is intended to encourage organizations to embed safety management and risk-based decision-making into all their activities, instead of superimposing another system onto their existing management system and governance structure. So what we're talking about is an integrated safety management framework within the design maintenance, the design system, management system. So being compliant doesn't necessarily mean being safe. In the old days, we used to say, does the organization comply with the rules? Well, it may well comply with all the regulations laid down. But with SMS, the new question is, how well is this organization managing safety? Which means, what are the risks in the organization? How are they being mitigated? Is that mitigation of risk effective? And how do we know this is effective? By measuring it. That's how we do. So this is basically the elements of a standard SMS, which is a closed loop system, as shown here. It goes around in a continuous process of identifying hazards, assessing them, putting some kind of value or rating on the risk so we can set a priority from that. Then we develop mitigations or barriers and protections for the high priority risks in our organization. And then we implement them, and then we monitor to see what happens, to track that there are no emerging safety issues. So we have various measures to measure our performance. And if we do uncover some issues or determine that our mitigations aren't as effective as they should be, then we can readjust our safety actions and then continue to review performance in service. So this is the combination of those two elements in a design management system. It is the design assurance system, all those items there, those 5 blocks on the left. And secondly, the safety management system, which is the ICAO Annex 19 elements. So just to recap on the design assurance system, it needs an organization structure, obviously, with persons nominated. The documented processes are relating to the initiation and control of design right throughout the design and certification process, and for the management of subcontractors. Airworthiness section, which is the airworthiness function, is headed by the head of airworthiness in the design organisation, and that department will perform all liaison with the EASA on the certification programs it carries out. It's also responsible for developing the compliance guidelines within the manuals, and for monitoring the preparation of the compliance documentation, which is the MOC, means of compliance statements, ICAO, the instructions for continued airworthiness, and the operational suitability data, or OSD. They're the main outputs of the organisation, of the design assurance system, and it's the responsibility of the independent compliance verification function to make sure that they meet the requirements. So there's a lot going on in a Part 21J DOA. There's a lot of sub-functions which have to work together and also be independently monitored by an independent department under a compliance manager, a CM, to verify that the things that are laid down in the manuals for both design assurance and safety are being followed, and that there are no non-compliances. So that's the type of management structure we're talking about here for a DOA. A CEO, underneath him there will be a head of design who's responsible for the organisation and its approved documentation process, its documented process. The head of airworthiness, which looks after the demonstration of compliance and the verification of it, and also liaison with the regulator. And then we've got the head of independent monitoring, or compliance monitor, who independently monitors the entire design assurance system, and I think to some degree also the safety management system. This is the process by which you can apply the stages involved in obtaining a Subpart J organisational DOA approval. Obviously, it takes a while because you have to get your organisation together, the necessary personnel. You have to produce a handbook that has to be reviewed by EASA. And when they're happy with that and they come and audit your process in your facility, then you can be issued an approval. But it could take, I would imagine, at least a year to do that practice. In practice, it's not something you can accelerate very quickly because there's a lot of steps to go through. Well, once you get approval in your design organisation, there are different scope and categories which are identified by these codes, such as if you've got an A1 approval, you can do design and modifications on large aircraft, A2 on small aircraft, so different types of aircraft. So it would be, the scope of work might be working on large aeroplanes, and then the products or categories would be like Airbus A330, 320, Boeing 777, etc. And the same goes for the different categories of aircraft. Also, there are other identification codes for engines and APUs and appliances, avionics parts and engine parts, etc., pneumatic systems parts. So that's the scope and categories of your approval. Talk a little bit quickly about a Subpart G. A Subpart G organisation is an organisation which has the approval to manufacture aircraft parts and appliances in conformity with approved type certificate data. Now, the approval may be obtained from the regulator of the state of the operator in European countries, or directly from EASA in respect of countries that are outside the European Union. So if you're going to be a Part 21 Subpart G fully approved production organisation under EASA, you need to have an exposition. Again, it's a handbook, production organisation exposition, or POE. That's a handbook which shows the structure of the organisation, identifies capability and all the nominated persons. So very similar to the design organisation handbook. An important function of a production organisation are quality control and quality assurance procedures for physically checking parts as they're manufactured and checking conformity against design. And there will be a production organisation, POA. The organisation should have a formal interface with its related Part 21 design organisation. So we have an interface between the DOA and the POA. And so really that's quite important, because the design organisation will pass design information across to the manufacturing organisation, including drawings, specifications, etc. And that needs to be accepted, acknowledged, and any problems with it fed back to the design organisation. So, you know, we can consider issues such as manufacturing techniques, part marking, testing and conformity testing and quality control, calibration procedures. All these things have a strong relationship between production and the design organisation, which is defining the part. So really, since the production process is an inherent part of the type design, there must be an effective relationship between the two. This is very important. The DOA, the STC or type certificate holder, which is under a DOA, has to have a solid and documented interface to its production organisation partner. So airworthiness can't be assured otherwise. So what we're saying is you can have an airworthy product, but that interface needs to be there to ensure that the whole system operates properly. The responsibilities of the design organisation on their side are to assure that correct and timely transfer of airworthiness data, such as drawings or material specs, dimensions, processes, surface treatments, shipping conditions, quality requirements, all of those things are passed over to the production organisation for their digestion and incorporation. And in the other direction, the production approval organisation, the POA holder, has to develop its own manufacturing data in compliance with the airworthiness data package. And if it has any questions about that, it will need to refer to the design organisation. So also the POA is responsible for ensuring traceability of its manufactured parts, releasing them to the outside world with a certificate of compliance or EASA Form 1. So it's an integrated system, really. The design and production system is how we get airworthy aircraft and airworthy parts produced under Part 21. So that's the conclusion of this module. Thank you very much for listening.